let me invite Mr. Ramakrishna Srinivasa, who is the CTO with Capgemini. To give you a background, a seasoned enterprise architect and chief technology officer with a strong background in technology strategy, architecture, and innovation. With over 25 years of experience in the field, he has a proven track record of translating CX business strategy into impactful CX technical solution to drive digital transformation and business growth. Can we have Mr. Ramakrishna with big round of applause, please?
Good afternoon all. Welcome to the session on edge computing, which is one of the key tenets of digital transformation. A lot has been covered in the last 2-3 hours, I would say, because when I started making this slide, I did not exactly know what were the topics which were being presented before. But still, we'll keep it short. We will keep it precise. I will just try to cover the important points for all of you. So first, we will look at what is the need for edge computing. It has been there, I would say, for almost 6 to 7 years now. It started somewhere around 2012-13. It was implemented by various organizations from 2015. So I would say it's close to a decade that it's been there. So what is the need for us to talk about edge computing now? What's new, how organizations are using it, etc., etc. We'll look at the functional overview and the architectural overview. And finally, we will look at how edge computing is helping digital transformation. Okay. So those are some of the things we will look at. So if you look at the current scheme of things, and if you look at this summit, this is all about data center, all about cloud, all about how we can maximize output from cloud, how we can use the cloud, how you can move every application that is running in-house to the cloud, etc., etc. But edge computing comes from an entirely different paradigm. So at this point in time, close to 20% of the enterprise data is on edge. And the prediction is that in another 3 to 4 years, close to 75% of the data will be on edge. So it is of course an entirely different paradigm. We have to see how the cloud will be leveraged. We'll have to see how the data centers will be leveraged. But yes, it all started with a PC when the complete power was with the person who was using it. In the last couple of decades, it moved entirely to cloud. Now in a different form, it is coming back. Okay. Or if you go back another 30, 40 years, it all started with mainframe, where everything was on server. Then it came to a PC. Then it went to cloud, and now it is edge computing. So it is slowly shifting. But then edge is here to stay. There were a lot of security concerns. There were a lot of hacks. In fact, every other hack that you see, I would say 50% of the hacks that you see on the newspaper, that you read on any news, is mostly because of edge computing. It's mostly because of the devices that you use in IoT, which are not sufficiently secured. It is mostly because of the way the network is configured, which is not sufficiently secured. It is mostly because of the ad hoc ways in which it is being implemented. Okay. But then, if you look at the news, it is that close to 75% or 80% of the computing power will move to the edge. And we'll also see the reason why. So if you look at some of the problems that we have with the current scheme of things, where everything is on cloud, which is what the last 3 hours were mostly about. How you can move it to cloud, how you can secure it, how you can improve your operational expenses, how you can decrease your capital expenses, and how as an organization you can be more and more profitable. But then one of the biggest challenges is the latency. So as you keep storing more and more data on the cloud, it is not available to you at an almost real time when you want to access it. It is not available to you during the month end, during the year end when you want hundreds of reports. It's not that it's not available, but it takes more time for you to make those things, right? So there is a challenge there, and that challenge is being solved by edge computing, because a lot of data in edge computing will still be stored on the cloud. Of course, if you look at in the last 2-3 years, there has been a lot of innovation. It is no more edge being separate. It is no more data being transmitted. Now you have got integrated networks and integrated clouds. We'll also look at a couple of them. So if you look at the landscape, it is changing. Okay, I think one of the previous speakers told, if you ask me where data is stored, it is stored everywhere. It's no more data in the cloud. It's data in the cloud. It's data in the servers. It is data in some local servers. It is data in the edge. So it's all everywhere. Yes. So it is going to be everywhere. So the second challenge is definitely with respect to how much of real-time monitoring you can do on every device that you have. So if you look at an automobile, especially in the last 3 years, you see all connected cars, you see all connected vehicles, And if you see some of the Indian models like Mahindra XUV500, XUV700, they contain a lot of data, and they keep transmitting it as well. So how much of data is available to you all the time is really going to be difficult, because if you are driving to some remote places, it's not possible for your connection to transmit all the data. You need to do some real-time monitoring. You need to do some real-time computing. You need to take decisions then and there when the vehicle is moving, right? So which is where when you talk about real-time monitoring, edge computing plays a really big role, specifically in automobiles and the healthcare sector is where this is being implemented. And then of course the large data transfer pipeline. It's not only because the devices are increasing, it is also because how much data you want to collect. So when it started in the automobiles, maybe around 4 to 5 years back, it was around 25 parameters, starting from the tire pressure, starting from temperature, starting from the skid, starting from the condition of the road, etc. But now they are actually gathering hundreds of parameters. Every automobile manufacturer, they want everything, right from the number of vehicles moving by the side of your vehicle, number of vehicles which are ahead of you, number of vehicles behind you, so that they can apply ABS, so that they can alert you when something is coming close by, etc. So the amount of data is increasing, and how much of the data you want to transfer is a decision which everybody has to make, which is why edge computing gains even a better edge. And the last one is, of course, how much of processing, how much of computing you can do, and also take a decision. So in the healthcare sector, it is called CDSS, which is computing real-time systems and decision making on real time. It is definitely used a lot both in automotive and healthcare. So yes, so finally, just to conclude, edge computing is not to replace cloud computing. Edge computing is not to replace the PC computing. Edge computing is more to complement everything that is going on. But then the importance is increasing, the number of devices are increasing, the number of manufacturers are increasing, and the cost is also decreasing. If you wanted to buy a sensor 5 years back for an automobile, it would have costed you somewhere around 800 to or at least 1,000 rupees. Right now it is 100 rupees. Okay. You want to buy any sensor. For example, if you want to buy a tire pressure monitoring system for your car, which doesn't have a tire pressure monitoring, if you go to Amazon, you can buy the sensor, the notification, and the mobile app, everything at 2,000 rupees. Okay. So if you look at only the sensor, it's possibly somewhere around 100 or 200 rupees. So the cost has come down rapidly, and the computing has also increased a lot. Moving on to the next slide. So this is more to give a functional overview of how the edge computing works, of where the data is stored, of how the whole network happens. Now, is this the way it is working today? No. Okay. As on date, if you see, when you started with cloud, every organization was only going to Amazon or was only going to Microsoft. In fact, they all started with Amazon, right? Because they were the first people almost a decade back. Later, it was an entry by Microsoft. Later, it was an entry by Google. Of course, everybody started giving free. Anybody who had Amazon Cloud, Google used to give the same services at half the cost, and same was done by Microsoft as well. So now if you look at every enterprise has got a hybrid cloud strategy. So it is more and more difficult to manage. You need a separate set of software to just monitor your cloud. Now there is another complication to it. It's not just hybrid cloud, it's an integrated cloud. An integrated cloud from your data center to every other device that you have. So it starts with your data center, it synchronizes with all the data centers which you have in the country, which means it is across the country, and then it goes to the edge as well. So it's a complete integrated cloud which you have. And if you look at IBM, they have something called IBM Cloud Satellite. If you look at Red Hat, they have got something called Red Hat OpenShift. So the advantage with these clouds is that when you deploy something using Kubernetes or using any other software, it is not just a deployment on cloud, but you deploy it on the edge as well. So it's a kind of completely integrated environment. So whatever you see here is something which was possibly the right diagram a couple of years back. But now if you see, this whole thing is integrated, and every cloud provider is giving you everything that you need as an enterprise organization to integrate it end to end. Okay. And getting on to what are the models of edge computing. Okay. So what you see here is once again a very simplified system of architecture, because I was not aware what is the kind of audience. I didn't want to have a complex diagram here. So if you look at edge computing models, you can say broadly there are 4 different models. Type 1 and type 2 have been unsuccessful, which is more ad hoc and tactical. For some of you who are staying in independent houses, you might have a monitoring system, or even for apartments, you might have a couple of cameras. You will just install the cameras. You will just have an app, and you will keep seeing it. It will work for a year, great. For 2 years, it will work great. And the 3rd year, one of the camera will get spoiled, and then the whole system falls flat. Okay, you never repair the camera. You never call him. Even if you call him, he charges the same money which he took to install everything. So you think it is not viable, and possibly by 3rd year, you think you didn't see any advantage of that, right? So those are some of the examples of ad hoc or tactical systems. Right now, what you have in the last 3 years is more about an integrated and a super integrated system, which means that when you see a dashboard, for example, for people who are using cloud, if you see the GCP or AWS or Azure, you get a dashboard which shows you everything at the end of the day, right? So in the same dashboard, you will be able to see everything that you are doing at the edge as well, when we talk about an integrated or a super integrated system. A super integrated is more transformational architecture, or is more required for major transformational projects. For example, one of the example I stated in the previous slide, IBM and Airtel together developed that cloud, and that is being implemented across the Maruti vehicles in India. Okay, so for Maruti, if they have to monitor, say, 100 lakh vehicles that you have, which are having the latest system, and if they have to take real-time decisions, if they have to update the software in real time, if they have to update the maps in real time, if they have to update the service data in real time, then what they need is a super integrated cloud. And super integrated cloud is more about edge first business, like how we spoke about customer first, how we spoke about cloud first. Now it is edge first business. Okay, so of course, when you go for transformational edge first business, it definitely requires a lot of planning. It definitely requires you to clearly understand what is it that you want to do at edge. If you look at a BMW, you don't have to take it for servicing at every 10,000 or 15,000 kilometers. You will have to take it for a service only when there is a need. Okay, same for Benz as well. So if you want to have that kind of a computing power, where all the 140 or 150 parameters which a service guy checks in the service center in a checklist, if you want the same computing power to happen in your vehicle and to tell you that you need a service now or you don't need a service now, you definitely need a transformational edge first business, which means you'll definitely have to do a lot more planning than installing cameras in your home or installing any kind of security in your home or any other IoT. Okay, but type 3 and type 4 have been extremely successful. Most organizations are now going for type 3 and type 4. Okay, which means edge is no more an edge. It is not about install and forget. It is about an integrated system. Okay. And then we look at what are the factors contributing to the success. Why are we talking about edge computing now? 5G has definitely been a major transformation factor, which has helped not just edge computing, but which helped many other things. So 5G is a major contribution factor, which has made edge computing very easy. It's not about the computing. It's not just about the computing. It is also about how much of decisions you make and how much of decisions you transmit to the cloud saying that you are making, so that the organization gets to know what is happening exactly on the site, or what is happening on the ship, what is happening on the vehicle, on the car, or what is happening in the home. So 5G has played an important role. Containers, if you look at Kubernetes, if you look at any of the other softwares which are being used, they were more for cloud only deployments. At least that is the way it started, right? And then it became hybrid cloud deployment. Now it is also about hybrid cloud and edge deployment powers it gives. Services and data mesh, yes, services and data mesh have clearly played a role in giving you the right amount of storage, in giving you the right amount of services to calculate, to call the requisite APIs, to take the required decisions. Software-defined networking, I know a few gentlemen spoke about how the networking has improved, how you are able to get the right devices. Software-defined networking is more about which all the telcos want to do. They don't want to do any configuration in the hardware. Instead, they want it to happen on the click of a button, like how it happens in a GCP or in an AWS. So software-defined networking played an important role in getting this edge computing back to power. But if you are buying any new vehicle, which I told, if you buy an XUV 500, if you buy an XUV 400, if you buy any of these, you will realize that it at least takes a week for your complete system to work, which is where they are actually setting it up. Setting up your vehicle to connect to the cloud and to make it work. For some of you, it may work on day one, but for some of you who would have realized, it at least takes a week to have the complete integrated cloud environment work. Okay, and then the digital twin. So for most of the equipments which are running on site, say if you take a wind turbine, if you take a ship, if you take a power turbine, where it is very difficult for humans to reach, digital twin has played a much bigger role in the last few years for predictive maintenance, for predictive servicing, for operational efficiencies, etc. And this whole thing has been made possible by edge computing. For that matter, even if you take the solar powered sensors, right? Earlier, if you had to install a solar power at your home or in a farm, it just used to be facing the sun, and they used to put it in the south direction where it gets maximum sunshine. Now you see that it actually rotates with the sun in the direction of the sun. That is once again made possible by a sensor, by edge computing, by 5G, by everything. So yes, it is there everywhere, and I think it is not just about computing anymore. It's not just about edge computing anymore. It is more about integrated cloud environment and integrated transformational edge computing that is going to change the world. Thank you all.